S. Chan presents educational video lectures as per the new UGC CBCS curriculum. Absolutely free. Difficult concepts made easy. Study anywhere, anytime.
Hello everyone, we know about curves. Curves we know, but do we know how we can calculate the bend in a curve? So if you want to learn, let's learn the radius of the curvature and asymptote. Why we learn? Because we want to know if there is any line which moves with the curve but never touches the curve. That also helps in curve tracing. So let's learn curvature, radius of curvature and asymptotes. Hi, I am Dr. Seema Thakran. Welcome to S. Chand Academy. If you want to study this topic, curvature, asymptotes and singular points, please refer to this book by S. Chand Publishing. The e-book link of the book is in the description box, so you can refer the book. Let's start with curvature, asymptotes and singular points. So, I will start with curvature first. For the curvature, what is important? The radius of curvature. So, radius of curvature. Radius of curvature, the notation is rho. This is the notation, and in short what we write ROC, that is radius of curvature. And the formula goes like, suppose your curve is y is equal to fx. So, it means first derivative will be y1, second derivative will be y2. In some books you will find the notation y dash and y double dash. I will be using these notations. So, however you are comfortable, you can. The formula is 1 plus y1 square to the power 3 by 2 upon y2. Now, in this formula, in case your y2 is negative, what you will do? You will be using this formula. y1 square, you will take the mod then, because radius, this value you can't take it as negative. So, this will be the formula. So, you will be having a curve, for radius of curvature 1 plus y1 square to the power 3 by 2 upon y2. If in case it is negative, the second derivative is negative, so you will be taking the modulus. Now, so let's start with the question. Prove that the radius of curvature at a point theta of the cycloid x equal to a theta plus sin theta, y equal to a 1 minus cos theta is this. So, this is the question. Well, start with, as radius of curvature formula I have already told you what was the formula. So, solution, the formula, and rho was the notation, and the formula was for 1 plus the first derivative square to the power 3 by 2 upon y2, and ultimately it should give you the answer 4a cos theta by 2. Let's start. So, but my equations are not in that form. So, we have to first club the how to take derivative if your x and y are given in this form. So, the derivative will be, so in this question the derivative will go like dy by dx. So, but y is function of theta. So, dy by d theta, this is how you will be taking the derivative. Direct derivative you are not getting. Y derivative with respect to theta, then x derivative with respect to theta, this combined will give you dy by dx. Put up the values. Y derivative with respect to theta will give you cos theta derivative is minus sin theta. So, ultimately your value will become this a sin theta, then the derivative this one 1 plus cos theta, a will get cancelled, and this you have to simplify a little bit, because in your proof in the last part you have angle theta by 2. So, you will be applying sin 2 theta formula. So, this will give you sin theta by 2 cos theta by 2, because 2 theta is this is you will be considering it as 2 theta. So, the angle will become half. 1 plus cos 2 theta is 2 cos square theta by 2, 2 get cancelled, cos will get cancelled, ultimately this is tan theta by 2. This is your first derivative, or you can say this is y1. So, y1 we have got as tan theta by 2. For y2, the derivative will be secant square theta by 2, and angle derivative because theta and this is with respect to x. So, this will be half into d theta by dx. This anyhow do not write it as 1 because this is the theta derivative with respect to x. You will be writing it in this form, x is a function of theta. So, you will not be missing this part. So, this is ultimately giving you secant square theta by 2 upon 2, and you have already dx by d theta, that is cos square theta by 2. You will be just reversing it. So, it will give you 1 upon cos square, because you will be just this is dx by d theta, just reverse of this 1 upon, you can write it as, if you have any confusion, you can write it as half 1 upon dx by d theta. So, your dx by d theta is cos square theta by 2, and this is your secant square. Secant square is again 1 upon, and this a is also there. Some of the things you might not be missing, a and 2 is also there. So, this is 4a, substitute carefully, 4a and cos 4, because this is again 1 upon cos square theta. This step you write carefully. So, I will explain. This is secant square theta 1 upon 2 d theta by dx. So, d theta by dx you can write as 1 upon dx by d theta. Dx by d theta is this one. So, it is a1 plus cos theta a, and 1 plus cos theta you can write as 2 cos square theta by 2. So, 1 upon 4a outside, then 1 upon cos to the power 4, because 2 from this 1 upon cos square, ultimately this is your y2. Now, you can move to the formula y1 y2, your y1 is tan theta by 2. So, rho formula is 1 plus y1 square to the power 3 by 2 upon y2. So, 1 plus y1 square is tan square theta by 2 to the power 3 by 2 upon y2. So, this y2 is, you can see it is in 1 upon form. So, it will come in multiplication. So, it is 4a cos 4 theta by 2. It will just gets reverse. So, 4a is fine. This is secant cube theta will lift, because this is secant square theta by 2, 2 gets cancelled, secant cube theta by 2 and cos 4 theta by 2, when you will cancel it, this will get 1 upon cos 3 power, 4 power, 3 gets cancelled, only you will left with this. So, this is the row answer we were supposed to prove, and it is proved. Moving to the topic curvature. In curvature you will be calculating these 1 plus y1 square y2. So, similar problems you can refer to. Now, moving to asymptotes problem. Finding asymptotes. So, finding asymptotes, what is asymptote? Tangent, I told you that this the tangent touches the curve at one point, normal is perpendicular to the tangent. What is exactly asymptote? Asymptotes is a line, asymptote, suppose I am considering the rectangular hyperbola xy equal to 1. The asymptote for this curve are x equal to 0 and y equal to 0. It means x axis and y axis both are asymptote to this curve, and this is the curve. So, this is the asymptote. It means the curve will just be moving to with this line, but it will not be touching. It will be touching the curve at the infinity only. So for this curve, how we are getting the asymptotes? Asymptote is a line. It is a line again. Asymptote is a line touching the curve at infinity only, not exactly touching anyhow. It just moves with the curve and till infinity it moves. Anyhow, it looks like that it is touching, but it just goes very near to the curve, but it never seems like that it is touching, but we say that at infinity it is touching because it gets very near. So for this rectangular hyperbola, these are the asymptotes. How come we are getting the asymptotes and how they help in curve tracing part? That will be just, first we will learn how to calculate. So I will start with asymptotes parallel to x-axis and y-axis. So asymptotes parallel to x-axis and y-axis. How you will be calculating asymptotes parallel to x-axis and y-axis? What you do? Just see the curve equation. See the curve equation, completely write the equation in this form so that you can figure out the highest power of x and highest power of y. Here the highest power of x, you can see it is x cube. The coefficient of x cube is 1. So generally for parallel to x axis, what we do? Put the highest degree coefficient of x equal to 0. But anyhow in this case it is so absurd writing 1 equal to 0. It means there is no asymptote parallel to, there is no asymptote parallel to x-axis. Parallel to x-axis. So what we do? For x-axis, the coefficient of highest degree of x put equal to 0, but it should be, it should not be that you are not, if it is a constant and it cannot be equal to 0, it is absurd thing. So it means there is no asymptote. Now coming to y. For y, you can see highest power is 2 and highest power 2 coefficient is x minus a. If you are combining this, the coefficient is x minus a. So it means when you are calculating parallel to y axis, what you will do? Parallel to y axis, the highest degree coefficient of y you will be putting equal to 0. It means x equal to a is the asymptote. And how you draw x equal to a line? This is your x axis, this is your a. It means if you know the curve, this line will be asymptote. It means this line will go with the curve till infinity and it will not be touching that way, but it will be just near to the, it will go with the curve till infinity. That is the point. It will not be touching. So x equal to a is the asymptote in this case. One question. So let's take a break, and before going to the break I am giving you one question, so you can practice that question. You can solve and you can find the asymptote parallel to x-axis and y-axis. So I am giving you one question, and the question is, for this question you can find asymptotes parallel to x-axis and y-axis. After the break I will give you the solution.
Welcome to S. Chand Academy. Myself Dr. Mamta Sethi, and I am here to explain you the various concepts related to the states of matter and chemical kinetics. So stay connected, like, subscribe and share, and do not forget to press the bell icon.
Welcome back to S. Chand Academy. So before going to the break I give you one question. I hope you did it. But in case you missed or you are not able to, let's see the solution. So as I told you, for asymptotes parallel to x-axis, if you are finding parallel to x-axis, what to do? Highest power of x coefficients. So this is the highest power. I just write it in a way. you can see if you are talking about highest power of x, you should write this equation in this form. So what is highest power of x coefficient? This is y square minus a square. So parallel to x axis, put this coefficient equal to 0. It means in this case you are getting the asymptotes y equal to plus minus a, and I hope you know how to draw these lines. Now for parallel to y axis. For parallel to y axis, parallel to y axis, write the equation in a way where you can collect the coefficients of highest degree of y. Highest degree of y is how much? It is y square only, and y square coefficient is, you can see, x square minus a square y square minus a square x square. So you are collecting coefficients of the highest power of y, put it equal to 0. So this will give you x equal to plus minus. It means in this case both parallel to x axis and y axis, both asymptotes, both the cases are existing, parallel to x axis and parallel to y axis. These are the asymptotes, and you can draw also. So x equal to a, this is the line, x equal to minus a, this is the line, y equal to a, this is the line, y equal to minus a, this is the line. So these are the 4 asymptotes for this particular curve. Curve tracing we will be doing later. So now it is not that every time you will be getting asymptotes parallel to x axis, parallel to y axis. In that scenario, what we do? We find oblique asymptotes. How to find oblique asymptotes? Let us learn that. With the help of the example only we will be learning. Oblique asymptotes we call. In the cases where you do not have asymptotes parallel to x axis and y axis. In such cases we will be calculating this. So let us take one example. Find the asymptotes of the curve x cube plus y cube, one of the very important curve. In many competitive exams you will see directly, you will be given options that 4 lines you will be given, and you were asked to find out which asymptote is particularly for this curve. So you should be learning the answer for this question also if you will be appearing in competitive exams. So how to, now you can see the equation is x cube plus y cube minus 3xy equal to 0. You can see the coefficient of highest power of x is 1. You cannot put 1 equal to 0, this is absurd. Then again the same thing happening for y, 1 equal to 0. So it means there are no asymptotes parallel to x axis and y axis. But how to find oblique asymptotes? Just see the highest powers. This is 3, this is 3, this is 1 plus 1, 2. How you start finding oblique asymptotes? First consider, this is 3, so it means phi 3. You will start with this function phi 3 xy. In this function write all the values where the degree is 3. So x cube plus y cube. It means very first function will be this one because this is the highest power. Then the second power is phi 2. What you will do? Only one term having 2 degree, and there are no other terms. It means you can consider only phi 3 and phi 2. Now the next step is put x equal to 1 and y equal to m. This is second step for each question if there are no asymptotes parallel to x axis and y axis. So, and then after that when you are substituting x1 by m, the notation will be this. It means no, you will not write 1 comma m, it is just simply phi 3 m. So it will be 1 plus m cube. This will become phi 2 m will be minus 3a m simply. So after this, when you are after putting x1 by m, what you will do? Put phi 3 equal to 0. Put the highest degree 1. Phi 3 m equal to 0. What you will get? 1 plus m cube equal to 0. Open the formula, a cube plus b cube. So, a plus b, a square plus b square minus ab equal to 0 implies m is minus 1. When you will solve this equation, it will give you complex roots. Don't consider complex roots because in asymptotes we consider only real values. Okay. So, m you got to know minus 1. Now, what you will do, any line equation you know, any line equation is of the form y is equal to mx plus c. So, it means m we got to know minus 1, c only we will be just calculating. In this case, how you will find c? There is a particular formula. So, for c, what do you do? This is the highest power, this is the lowest power, just next lower power. So, phi to m and highest power derivative you will be writing with a negative sign. This is the formula, negative sign phi 2m upon phi 3 dash m. Phi 2m is how much? Phi 2m is minus 3am. Already there is a minus sign, so you can put a plus sign. Phi 3 dash m will be 3m square. Do the calculation and put the value m equal to minus 1 to get the value of c. So, 3 a by m only and m is minus 1. So, this is giving you minus a. C you got to know, m you got to know, therefore, the equation is y is equal to mx, m is negative and your c is also negative. This is very important question. So, somehow we always suggest that you learn the equation of the asymptote also because it comes, so it is very common. This question is very common and it comes in many competitive exams. Directly they give the curve and so many options like this. They give the options like this. Choose the correct asymptote equation. So, you should be knowing because this question generally many a times you will see in many exams, even in Delhi University honors exam, past course exam. So, you should learn this equation. So, after this, let us take one more example because in this case only one root we were getting. It might happen that in some of the equations we get multiple roots. So, for that, let us consider the last question of this topic, asymptotes. We have taken one question in which only m value was not repeating. In case it is repeating, how to solve such a problem. The same way, now you just mark the degrees. This is 3, 3, 3. You can see 2 plus 1, 3, 1 plus 2, 3. It means your phi 3 xy is x cube minus y cube plus x square y minus xy square. This is your phi 3 because all are having degree 3. Now, phi 2 will be, this is 2 degree, this is 2 degree. So, this much only for phi 2. And now, phi 1, only 1 powers, it means this much only. Do not take this 1 because it is not of 1 degree. So, this is your phi 3, phi 2, phi 1 and quickly now put x equal to 1, y m and one more thing, phi 3 m equal to 0 also. These two steps you can do together. So, phi 3 m will be how much? 1 minus m cube plus m minus m square equal to 0. Then phi 2 m will be minus 2 plus m square, that is it, and phi 1 m will be 1 plus m. Simplify this equation to get the values of m. So, 1 minus 1 plus m, I am combining this and just take out m square minus m square common. You will left with 1 plus m equal to 0, 1 plus throughout because in this also it is common, take out this outside. So, 1 minus m square. So, m, what values of m you are getting? Minus 1 and from here it is plus minus 1. So, it means 1 is not repeating but minus 1 is repeating and it is repeating twice. So, if the value is not repeating, the same process in the last question as we did, but if it is repeating, then how you will be solving? First I am taking the same case, M1 I am taking. For M1 you will be calculating C. How you are calculating? The same way. The highest power was phi 3. So, the derivative here you will be writing and phi 2 m with a negative sign. So, phi 3 derivative of this term, what it will be? Minus 3m square plus 1 minus 2m and minus phi 2m. This is your phi 2m. Put the value 1 in this. What you are getting? Negative of 1 if you are substituting. So, minus 1, then minus 3 plus 1 minus 2, 1 upon minus 4. So, this is your C value. Okay, now after calculating the roots, please I missed this 2, do not forget it, because when you are substituting x1 by m, so this will give you minus 2 plus 2m square. So, this is minus 2 plus 2m square. Now, for m1 we are calculating C. C formula is, this is the highest power, this is the highest power derivative you will be writing, then minus phi 2m and you will be substituting m value here. So, this is your phi 2, 2m square, and derivative you will be writing, derivative of this. So, this is minus 3m square plus 1 minus 2m. When you are substituting 1, it is giving you minus 2 plus 2. So, 0 by any number, that is minus 3 plus 1, it is completely 0. So, in this case for M1, C is 0. Therefore, in this case asymptote is y is equal to mx plus c. Your m is 1. So, simply x plus 0. So, it is this equation. Now, moving to when the root is repeating, how you will be calculating your C value? When your root is repeating, m is minus 1. When it repeats, how you write the formula? So, in that case, for m equal to minus 1, your formula will go like C square by 2, because it is twice time it is repeating, then phi 3 double dash m, second derivative concept you will be just getting in this, C phi 2 dash m, and the last is phi 1 m equal to 0. Please, because this is a big formula. So, it was repeating twice. So, C square by 2. This is the highest degree and second derivative of that degree. Then C, then the lowest after 3, the phi 2 we have, first derivative you will be taking, and in the last phi 1 m. This is how you write the formula. Put up the values. So, C square by 2, this time you are you will be taking the second derivative now. So, second means what? Just see, this is first derivative now, phi 3 dash m. So, take one more derivative, you will get this value. So, minus 6m minus 2, this is the derivative. Now, phi 2 dash m you have to substitute. So, C, what is your phi 2? This is your phi 2, simply the derivative, this will be 0, it will be 4m only. And now, the last part is phi 1 m. So, what is your phi 1? This is simply 1 plus m, so derivative will be 1. And this equation, simply put m equal to minus 1 carefully. So, C square by 2, when you are substituting minus 1, so this will give you 4 only. This will give you minus 4C plus 1, cancel it. So, 2C square minus 4C plus 1. Now, if you do not know how to calculate this, what values you will be calculating? C minus B plus minus B square, so 16 minus 4AC upon 2, 8. So, this is your 2 under root 2 you cancel it and these are the values. So, C values for m equal to -1. So, now C square by 2 phi 3 dash double derivative, this is the double derivative. Phi 1 m was 1 plus 1 plus m equal to 0. Put the value m equal to -1, this will give you 4, this will give you minus 4c and -1 you are substituting, so this will become 0. 1 minus 1, 0. So, it is 2c square minus 4c equal to 0, c 2c common, c minus 2. So, this implies c 0 and c equal to 2 corresponding to m equal to -1. It means this time we are getting two asymptotes. The asymptotes equations are asymptotes are y is equal to mx plus c. First take this combination c0 m minus 1, c0 m minus 1 and for the other c2 m minus 1. For corresponding to m minus 1 you are getting two values because it was repeating twice. So, these are the answer for the asymptotes. So, this is all about this lecture. In this lecture we have covered curvature, radius of curvature, asymptotes, parallel to x-axis, parallel to y-axis, oblique asymptotes also we calculated in this lecture. If you want to study this topic in detail, you can refer to the book by S. Chand Publishing. The link of the e-book is mentioned in the description box below. Please like, share and subscribe to S. Chand Academy. Don't forget to press the bell icon for the future updates.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.